Hello everyone, welcome to another tutorial. In this Proteus tutorial, I will teach you how to simulate the 555 timer in Proteus in the Astable Multivibrator mode. So this is how the final simulation looks like. As you can see, we are turning an LED on and off, and this is a demonstration of the operation of the 555 timer in Astable mode. We have connected the output to a digital oscillator. So as you can see here, we are also able to display the waveform. So at the end of the simulation, you'll be able to do exactly this. So let's get started. So here is how the circuit looks like. We have 4 external components which will be connected in addition to the 555 timer. We have R1, we have R2, and then we have C. Now R1, R2, and C sets the on and off time for each cycle. So let's move straight to Proteus and then we'll simulate and see how it works. Okay, so we have Proteus launched and then a new project open. The first thing we are going to do is to pick the components we need and place it at this section of the program. So we click on, we go to component selection mode and click on P. So we type in the components we need. First we need a 555 timer. So I type in 555 and then I double click 555 from here. Next we need the resistor. We type in RES, then we can choose a resistor from here. Then we need a capacitor, so we type in CAP and then we have a capacitor here. Then our last component is an LED, and we want to be able to see the LED come on and off, and Proteus have animated versions of components, so we type animated LED and we can choose the color we want, so we'll choose green here. Now when we are done, we click OK and we have all the components at this section. The next thing we are going to do is to place the components on the sheet. Now we place our 555 timer first, and we can place the rest of the components around it. So I'm going to do that for all the components. After placing all the components onto the sheet, the next thing we are going to do is to arrange the components like we have in the circuit. And we are using this circuit for the simulation. And I know the circuit in my head, so I am not going to look at it. But if you don't know the circuit in your head, you can refer and look on it to place the component or to connect your component. So we go back to Proteus. So now that I am done arranging my components, I will connect them together. So I just click on the edge of one component and then drag it. I'm going to do the same for all the components and connect all of them together like we saw in the circuit. So now all the components are connected together. Now the next thing to do is to connect our power supply. So we come to a terminals mode, we go to ground and we can connect our ground here. Then we go to power and we can connect our power over here like we saw in the circuit. So we need to specify the supply voltage. So we double click and we enter the voltage we want. So I want to use 5 volts. I'll type in 5 volts. And you need to start with plus 5 volts. Now we also need to change the values of the components to the values we want to use. So for this capacitor, I will use 10 microfarad. So I'll type in 10 UF or 10 U. And for this one, I'll use 10 nanofarad. So I'll just type in 10 nanofarad. And I'll leave the resistors at 10K each. Now I want to be able to see the output waveform of the 555 timer on a virtual oscilloscope. So I will come here and choose oscilloscope. Then I can connect. So when you finish with everything, you click on play and then you can see the simulation. So as you can see, the LED is going on and off, and we have the output waveform on this channel. So you can adjust the settings of the virtual oscilloscope to get a better waveform. Yes. So here we can see the output on the oscilloscope. Now let's see what happens when we change the values of the resistor and the capacitor. So to change the values, I will press stop. Then I can go and increase this one to, let's say, 47 ohms. And I can go and increase this one to 15K. Now let's see what will happen. When I click play, you see that it is not flashing as fast as it used to, and you can see that the output waveform has also changed, and the on time is longer and the off time too is longer. Let's see what happens when we change this resistor, the value of this resistor. So I'll click stop again. Let me make this one 20K. So you see that the on time is much longer than the off time, and then the waveform has also changed. We can adjust it to see how it looks like. It shows that the waveform or the output waveform and the on and off times of the LED is dependent on the three components: this resistor here, and this capacitor here. You can read more about how it works in the link below. So that is all for today. Thank you.